Hi there. Today, we're going on a journey into the hidden language of data. The tiny invisible units that power every text message, video, photo, and even the apps on your phone. You've probably heard of terms like megabytes, gigabytes, and terabytes. But do you know what comes after them? Or how massive some of these units really are? By the end of this video, you'll not only know all the storage units, from the smallest bit to the mind-boggling Quettabyte, but you'll also understand why the world is generating more data than ever before. Let's start at the very beginning. Bit. The smallest unit of data in a computer is called a bit. That's Byte. A bit can only have two values, 0 or 1. Think of it like a tiny light switch. Off is 0, on is 1. Simple, right? But this simplicity is the foundation of everything digital. Every single photo you've taken, every video you've streamed, every message you've sent, all of it is built from billions, even trillions of bits flipping on and off. Alone, a bit doesn't tell much, but when combined with other bits, magic happens. Next up is the byte, represented by the capital B. One byte is made of 8 bits. Why 8? Because 8 bits together can represent 256 different values, which is enough to store a single character, a letter, number, or symbol. For example, the letter A in your text message is stored as a unique byte pattern. Imagine typing a 100-character message. That's already 100 bytes of data. Bytes are like digital atoms, small on their own, but when combined, they can form something much bigger. Kilobyte. From here, things start to grow fast. A kilobyte, or KB, is 1,000 bytes. That's roughly enough to store a short paragraph of text. In the early days of computing, entire programs, games, and documents fit into just a few kilobytes. Floppy disks, for example, held only a few hundred kilobytes, yet people were already creating documents, playing games, and even running small software businesses with them. Kilobytes were the stepping stone to bigger things. Megabyte. Next, we have the megabyte MB, which equals 1,000 kilobytes, or about 1 million bytes. 1 MB can store a short song, a small image, or a short video clip. In the 1990s, having a computer with 500 megabytes of storage felt like a luxury. That was enough to hold thousands of documents or an entire music library. Today, a single photo on your phone often exceeds 1 megabyte, showing just how fast storage needs have grown. Gigabyte. Moving on, a gigabyte GB equals 1,000 megabytes, or roughly 1 billion bytes. 1 GB can hold about 600 photos, 230 songs, or a 2-hour HD movie. In the early 2000s, a 20 gigabytes hard drive was considered enormous. Today, even smartphones start with 64 gigabytes or more. Every app, game, and operating system you use is measured in gigabytes. It's fascinating to think that a single gigabyte of plain text could store thousands of novels, a miniature digital library right in your pocket. Terabyte. Next comes the terabyte TB, equal to 1,000 gigabytes or a trillion bytes. A single terabyte can store around 250,000 songs, 500 hours of HD video, or millions of documents. Modern laptops, gaming consoles, and external drives now come with 1 to 2 terabytes as standard. Cloud storage services also offer terabytes of space, making backups and file sharing seamless. To put it into perspective, if you tried to store the entire Library of Congress's text collection, it would fit into about 10 terabytes, meaning your home drive could almost rival one of the largest archives on Earth. Petabyte. Now, things start to feel massive. A petabyte PB equals 1,000 terabytes, or a quadrillion bytes. 1 petabyte can hold about 13 years of non-stop HD video. Companies like Netflix, Google, and Amazon manage data at the petabyte scale every day. Just imagine the storage needed to stream billions of movies, songs, and images around the world. Petabytes are not something an average person deals with, but for big tech, it's the standard unit of measurement. Exabyte. An exabyte EB is equal to 1,000 PB, or 1 quintillion bytes. Back in 2001, researchers estimated that the entire internet contained about 5 exabytes of data. Today, humanity generates more than that every single month. 1 exabyte could store a trillion books, or around 250 million DVDs. Managing data at this scale requires massive server farms running nonstop, an entire warehouse dedicated to keeping the digital world accessible. Zettabyte. A zettabyte ZB equals 1,000 exabytes, or a sextillion bytes. Global internet traffic in 2020 alone reached around 4 ZB, encompassing every photo, video, email, and social media post ever sent. 1 ZB could store 30 billion 4K movies, more than any human could watch in a lifetime. At this scale, data stops being human-sized and becomes planetary-sized. Cloud services, governments, and big tech now routinely talk in zettabytes when measuring worldwide data flows. Yottabyte. The Yottabyte YB is 1,000 ZB, or a septillion bytes. No system today can store a yottabyte, but it helps scientists and engineers imagine future growth. A single yottabyte could hold every document, photo, video, and song ever created in human history, with space left over. As our data generation grows exponentially, the yottabyte may eventually become necessary to measure the entire digital universe. Ronabyte. In 2022, the Ronabyte RB was officially introduced as 1,000 YB. That's a number so vast, it's almost impossible to visualize. To give some context, all the digital data humanity has ever created is still less than a single Ronabyte. It's a unit for the future, a way to measure unimaginable volumes of information. Quettabyte. Finally, we reach the Quettabyte QB, which equals 1,000 Ronabytes. At this scale, storage becomes almost science fiction territory. A Quettabyte could theoretically hold every piece of data humans could ever produce for centuries. While we may never reach it in our lifetimes, thinking about Quettabytes shows just how fast our digital universe is expanding. From a single bit to the colossal Quettabyte, each step is roughly 1,000 times larger than the last. What starts as a simple 0 or 1 can eventually scale up to store billions of movies, trillions of books, and all of humanity's digital memory. And here's the mind-blowing part. Humanity is moving through these units faster than ever. With AI, cloud computing, and 5G technology, data generation is skyrocketing. What was once unimaginable yesterday, like an exabyte of data, is now just part of our everyday digital life. If this video helped you understand data storage in a new way, make sure to like, subscribe, and hit the bell icon for more tech explained simply. Also, comment below which storage unit blew your mind the most. Was it the Yottabyte, Ronabyte, or Quettabyte? I'd love to know. Thanks for watching, and I'll see you in the next video.